Okay, so I'm going to try to do this a little quicker so you have less time. You spend less time watching what I'm talking about. So, what we're going to do now is we're going to look at chemical reactions. Chemical reactions, well, here's an example of a chemical equation which shows a chemical reaction. So by the end of this, you should be able to tell me what a chemical reaction is and how this shows what's happening during a chemical reaction. Okay, so a quick definition of a chemical reaction. Okay, a chemical reaction is a change in the arrangement of atoms or molecules to yield a substance of different composition and properties. Basically what it's saying is when you mix certain things together, an interaction happens where you get a new thing. For example, we have water, which is a liquid. We have these tablets, which are solids. Okay, each of these are their own compounds. Okay, we put them together, and an interaction happens that causes this gas to be created. We have a new substance being created. We had liquids and solids before. This solids are dissolving into liquid, creating a gas. There's a chemical change, a chemical reaction happening. So now there's no solid left, a gas, and a new liquid. Okay, so again, a chemical reaction is substances changing to a new substance with new properties. Okay, chemical formula. Chemical formula is basically just shorthand or representation of a compound or element. You know, so you know N, if you look on the periodic table, stands for nitrogen. H stands for hydrogen. These are the symbols. Okay. But we notice two other things. We have NH3. This 3 is a subscript. And it tells us how many atoms there are. So, it tells us there's 3 atoms of hydrogen, okay? And this large number, so the coefficient is always small and sort of under the letters. The large number is always in front, is a coefficient. Okay, it's a coefficient. It tells us the number of molecules. So this tells us the number of atoms, coefficient tells us the number of molecules. So there's 2 NH3 molecules. This is 1 molecule. Sorry. 1 molecule of ammonia. So number of molecules. Okay. A chemical equation is basically just a representation of a chemical reaction. Here we have hydrogen gas, oxygen gas, which gives us H2O, water. We have a coefficient, subscripts. Okay, you see the 2 G's and the L. This tells us the state of matter. Okay, so G, gas, L, liquid, S, solid. When you get into more advanced chemistry classes, you'll see different other states of matter. But this side is called the reactants. This side, the products. Okay. But this is just shorthand for what we're going to be looking at later. Okay. Law of conservation of mass, quick and dirty. Mass can't be created or destroyed. That's as simple as I can make it. If you start with a certain amount of product or reactant, you have to end with that same amount of product. So that's the scale represents that they have to be equal. Your products have to equal your reactants. Okay. So how do we apply the law of conservation of mass to chemical reactions? We see we have a chemical equation here. We have to make sure that we have the same number of atoms on each side, so we count them. So what we do is we list the elements on the reactant and product side, we have use the subscript. You see we have 2 hydrogen, 2 oxygen. Over here we have 2 hydrogen and 1 oxygen. This equation is not balanced. In chemistry, we always have to have a balanced equation. Okay. Which brings us to the end. How to balance an equation. Okay. So again, we start with counting 2 hydrogen. Because of the subscript tells us that there's 2 atoms of hydrogen. Same with the oxygen. And that's for the reactant side. On the product side, 2 hydrogen, 1 oxygen. Okay. So we need to get the oxygens balanced, since they're the ones that aren't. We have 2 here and 1 here. Looking back at the chemical formulas, we know we can add a coefficient. So what can we multiply by 1 to get 2? Okay, hopefully you should have said 2. Okay, so if we add that coefficient to this molecule of water, we can then multiply the 2 by the oxygen, and now we have 2. But we have to make sure that we update the hydrogen. Because now we have 2 hydrogen atoms, but in 2 molecules of water, which means we have 4 total hydrogen atoms. So we're still not balanced. We have 4 here, 2 here now. So we need to do the same thing over here. Had a coefficient of 2, multiply it out. Now we have 4. So this chemical equation is balanced. So remember, chemical reaction is when you get substances, there's an interaction and you get new substances with new properties. In chemistry, those substances and the new substances has to equal. You have to start with the same number of atoms on the reactant side as you do with the product side. That's the law of conservation of mass. We can't create mass. We have to work with what's there. And we have to work with the same type of elements and the same number of atoms. That's why we balance chemical equations.